this A we can write, for example, AC as A0 times exponential AC of t as A0 times exponential I omega t plus alpha. Okay. Then I can define this as A0 exponential I alpha times I omega t. So the original AT can be written as real part of AC of t, which is equal to the real part of A0 e to the I alpha e to the I omega t. Okay. So for convenience, we sometimes write AT as A0 e to the I alpha times exponential I omega t。我们有时候为了方便呢，我们直接就把它写成这样啊，我们就直接写成什么？我这边用这个 AC 这样子写好像不太好，我换个符号，我这边就我直接看这样子啊，我直接把什么叫 AC 啊？我换一下符号，抱歉，我直接把这个叫做 AC 好了，AC 1的 I omega t，OK， 这样子，好，这样比较方便一点啊。那 AC 这里呢 ，AC is equal to A0 exponential I alpha， 这样，好，那这时候呢，如果我用它的替身，好 ，originally AT is equal to this, which is a real quantity. However, we sometimes can represent the AT with its complex counterpart, and sometimes we do not distinguish the complex version and the real version for convenience. Once you want to know the real value, you just take the real part of this representation. In this representation, we may move this phase into the coefficient and define this as the complex amplitude. AC is the complex amplitude of this quantity A. Okay. Now we have a question. How to represent energy density 或者 quadratic energy density. Pointing vector. We want to know how to represent energy density Pointing vector in terms of complex field vectors. For the linear field vector, we can take the real part to represent the real physical field. However, how to represent the quadratic function of the field vectors? Can we still take the real part of the square of the field? No. This is because if we consider something like this, suppose I have A equal to some absolute value of A times cosine omega t plus alpha. Suppose I have this quantity, which can be written as real part of A e to the I omega t. Here, A is equal to A absolute value times the phase vector. Okay. And I consider another quantity, I call it B. Now it has phase beta, and I can write this as real part of B e I omega t. And here B is the absolute value of B times exponential I beta. Both are real quantities. Real quantities. Both are real quantities. Now if I consider the bilinear form, A times B, A can be equal to B, so we get A squared corresponding to energy density. And A can be proportional to B but not equal to B. For example, pointing vector equals H. So now we want to know how to represent A times B for use the complex notation. So this is equal to A absolute value times B absolute value times cosine omega t plus alpha times cosine omega t plus beta. Okay. And according to trigonometric functions formula, we have 三角函数的公式和差化积化和差你会得到什么呢？这两个相加跟相减 cosine 2 omega t plus alpha plus beta plus cosine alpha minus beta. We get these two terms. However, if you consider multiplying these two complex functions directly, you time them directly, you get AB times exponential I2 omega t, which is equal to A absolute value, B absolute value times exponential I2 omega t plus alpha plus beta. Okay, then if I take the